Welcome to this episode of the CompTIA Tech Plus Prepcast by baremetalcyber.com. Let's begin. Digital systems depend on standardized measurement units to describe their speed, size, and capacity in a way that is universally understood. Whether you are working with storage devices, network equipment, or processors, these units ensure that specifications are clear and comparable. On the CompTIA Tech Plus exam FC0-U71, you may be asked to recognize, compare, or convert between these units, often in scenarios where making the right choice depends on knowing the differences. This episode will focus on three major categories: storage size, data transfer rate, and processor speed, and explain why each matters in both exam and workplace contexts. Understanding these units is critical because it helps you make informed technical decisions and prevents costly mistakes. Misinterpreting a measurement can lead to buying incompatible hardware, diagnosing the wrong performance issue, or overbuilding a system and wasting resources. In the workplace, technicians and administrators rely on these numbers every day when troubleshooting, planning upgrades, or optimizing systems. Knowing exactly what a measurement means also communicates professionalism and accuracy to colleagues and clients. Storage units measure the amount of digital data that can be saved or retained in a device. The smallest possible unit is the bit, and the next is the byte. From there, values scale up in powers of 1024, giving you kilobytes, megabytes, gigabytes, terabytes, and petabytes. A byte contains 8 bits, and each higher unit represents a significant jump in capacity. These measurements appear everywhere from product packaging to cloud service dashboards, so fluency with them is essential. A bit is the smallest piece of digital information, representing either a 0 or a 1. 8 bits together form a byte, which is large enough to store a single text character or a small piece of instruction code. Storage devices like hard drives, flash drives, and memory cards are almost always measured in bytes, while data transfer rates are typically measured in bits. Being able to distinguish bits from bytes allows you to correctly interpret specifications and avoid false assumptions about performance. Common storage quantities follow the same scaling pattern. 1 kilobyte equals 1024 bytes. 1 megabyte equals 1024 kilobytes. 1 gigabyte equals 1024 megabytes, and 1 terabyte equals 1024 gigabytes. A petabyte is 1024 terabytes and is most often seen in enterprise-level or data center contexts. These units are used in file sizes, the capacity of local and external storage devices, and the storage limits of online services. Throughput, or data transfer rate, measures how fast data can be moved or processed over time. This value is typically expressed in bits per second, abbreviated as BPS. Metric prefixes like kilobits per second, megabits per second, and gigabits per second indicate scale. The higher the throughput, the faster data can be uploaded, downloaded, or transferred between systems. Understanding throughput is essential for tasks like selecting the right network hardware or determining whether a connection can support a certain workload. Real-world throughput examples help show how this measurement applies. A 100 megabits per second internet connection can move up to 100 million bits every second under ideal conditions. A file transfer may be limited by the throughput of a USB connection or by network bandwidth. Streaming high-definition video, syncing cloud backups, or running virtual desktops all depend on adequate throughput, and knowing these limits helps you diagnose lag or failed transfers. Storage capacity and transfer rate are related but measure entirely different things. A device might have a 1 terabyte drive but only a 100 megabit network card. The terabyte describes how much the device can hold, while the megabit rate describes how fast data can be sent or received. Confusing these numbers can lead to incorrect expectations about performance, so always check both when evaluating a system's capabilities. Processor speed is usually measured in megahertz or gigahertz, with 1 gigahertz equal to 1 billion cycles per second. A higher clock frequency typically means a processor can complete more tasks per second, but performance is also affected by architecture and other features. This measurement is critical in determining how well a CPU will handle a given workload, whether that's everyday office applications or high-performance computing. Putting CPU frequency into context helps you make better comparisons. A processor running at 3.5 gigahertz can theoretically complete 3.5 billion instruction cycles every second. Laptop processors may operate at lower gigahertz values but have efficiency features to extend battery life. Server CPUs may have lower clock speeds but many more cores to handle heavy multitasking. Matching CPU specifications to the specific needs of the user or system is the best way to ensure optimal performance. Core count is not a measurement unit, but is closely tied to performance. Multi-core processors split work across several processing units, allowing tasks to run in parallel. This improves responsiveness and makes multitasking more efficient. While gigahertz is still a key measurement, it should always be interpreted alongside core count and the type of workloads the processor will run. Each category of measurement applies to specific use cases. Storage measurements matter when buying hard drives, SSDs, or cloud storage space. Throughput measurements are essential for configuring and troubleshooting networks or planning large file transfers. Processor measurements determine how well a system will run applications, games, or virtual environments. Knowing which unit applies to which scenario will help you optimize both system design and everyday use. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. Prefixes in IT measurement units often mirror the metric system, but carry different meanings depending on context. For throughput, prefixes like kilo, mega, and giga are generally treated as powers of 10 1 kilobit equals 1,000 bits. In storage, however, the same prefixes are traditionally based on powers of 2 1 kilobyte equals 1,024 bytes. This subtle distinction is important because it explains why advertised storage sizes on packaging may not match the reported size once the device is connected to a system. Recognizing these conventions prevents confusion when interpreting specifications. The difference between bits and bytes becomes especially important in real-world marketing. Internet service providers usually advertise network speeds in megabits per second, abbreviated MBPs, while file sizes and download progress indicators are almost always shown in megabytes or gigabytes. To convert from a bit-based rate to a byte-based rate, you divide by 8. For example, a 100 Mbps internet plan has a theoretical maximum download speed of about 12.5 megabytes per second. This conversion is essential for setting realistic expectations about transfer times. Storage performance is measured not only in capacity, but also in read and write speeds, typically given in megabytes per second. Solid-state drives tend to outperform mechanical hard drives because they access data electronically rather than mechanically. NVMe drives, which use PCIe connections, push performance even further, reaching throughput levels that can drastically reduce load times for applications and operating systems. Understanding these speed ratings helps you choose storage that matches the demands of your workflow. Network performance metrics, such as those for network interface cards, routers, and switches, are usually rated in gigabits or megabits per second. Achieving the advertised speeds requires compatible infrastructure from end to end, meaning that the cabling, switches, and connected devices must all support the same standard. Wireless connections have similar ratings, but actual performance is influenced by factors like distance, interference, and the number of connected devices. Knowing the difference between theoretical and actual throughput is critical for accurate diagnostics. On the CompTech Plus exam, you may encounter questions that ask you to identify which unit is appropriate for a given scenario or to convert between units. You might need to determine whether a figure refers to storage, processing speed, or throughput. Being able to instantly recognize abbreviations like GHz for gigahertz or TB for terabytes helps you answer these questions quickly and accurately. Troubleshooting based on units is a skill that translates directly to the workplace. If file transfers are slow, checking network throughput is more relevant than checking storage capacity. If a system is sluggish during multitasking, examining processor gigahertz and RAM speed will be more informative than focusing on disk size. If storage space is running low, the important metric is remaining gigabytes or terabytes, not the drive's transfer rate. Matching the problem to the correct measurement speeds up resolution. When designing or purchasing systems, aligning units across components prevents mismatched performance. A high-speed network connection can be bottlenecked by a slow storage device, and a powerful CPU can be underutilized if network speeds or storage throughput are inadequate. Balancing storage capacity, throughput, and processing speed according to the intended workload is the most effective way to ensure smooth operation. In cloud computing environments, similar principles apply. Providers charge for both storage capacity, measured in gigabytes or terabytes, and bandwidth usage, measured in gigabytes transferred. Virtual CPUs are often measured in gigahertz equivalents, which indicate their performance level in a hosted environment. Understanding these measurements allows you to control costs, scale resources appropriately, and make informed service selections. It's helpful to memorize common abbreviations and their meanings. Lowercase b represents a bit, uppercase B represents a byte, K stands for kilo, M for mega, G for giga, T for tera, and P for peta. Hertz, abbreviated Hz, measures cycles per second, while BPS means bits per second and MBPs means megabytes per second. TB and GB are storage units, while GHz applies to processor speed. These abbreviations appear in both exam questions and product specifications. Tools like system monitors and network utilities are valuable for visualizing these metrics. A task manager or performance monitor can show CPU usage in gigahertz, RAM usage in gigabytes, and disk space in terabytes or as a percentage. Network monitoring tools can display transfer rates in MBPs or KBPs in real time. Learning how to read and interpret these displays reinforces your understanding of units outside of study materials. There are common pitfalls to watch out for. Confusing bits and bytes is one of the most frequent errors. Mixing throughput units with storage units can lead to incorrect assumptions about performance. Assuming that a higher gigahertz rating always equals better performance ignores the role of architecture and core count. Failing to check unit context when comparing specifications can lead to costly purchasing or configuration mistakes. Flashcards are a practical way to master units. Create cards with the unit's name on one side and its symbol, definition, and an example on the other. Include examples from real product listings so you learn to recognize how units appear in context. Practice with mixed flashcards to train yourself to identify whether a unit refers to storage, speed, or throughput. Repeated exposure will make recognition almost automatic. The main takeaway is that understanding IT measurement units is about more than passing the exam. It's about making informed, accurate decisions in real-world scenarios. Knowing how to read, interpret, and compare units enables you to choose the right hardware, diagnose problems efficiently, and communicate specifications clearly. In the next episode, we will move into troubleshooting methodology, breaking down the CompTIA recommended process for identifying, testing, and resolving technical issues. This structured approach will prepare you for exam questions and give you a proven framework you can apply in day-to-day IT work. Thanks for listening. Please visit baremetalcyber.com for more cybersecurity information and education, including a new children's series. For more information on books and more, follow us at cyberauthor.me.